Good day, my name is Ramical Punzalan, 3A PPO. Elliptic curve cryptography. What is elliptic curve cryptography? Elliptic curve cryptography, or ECC, is a powerful approach to cryptography and an alternative method from the well-known RSA. It is an approach used for public key encryption by utilizing the mathematics behind elliptic curve in order to generate security between key pairs. ECC has been slowly gaining in popularity over the past few years due to its ability to provide the same level of security as RSA with a much smaller key size. How does elliptic curve cryptography work? An elliptic curve can simply be illustrated as a set of points defined by the following equation. Based on the value given to A and B, this will determine the shape of curve. Elliptical curve cryptography uses this curve over finite fields to create a secret that only the private key holder is able to unlock. The larger the key size, the larger the curve, and the harder the problem is to solve. A basic example of how this form cryptography works is demonstrated in the following. Based on the value given to the points A and B, an equiliptic curve is drawn. A line can be drawn through those points until it reaches a third intersection point on the curve, which we can call point C. At this stage, when the line reaches its third intersects point, we can reflect that the points onto the other side of the x-axis. Continuing from point C, we can draw a line through from point A to point C, which intersects with another part of the curve, point D. This point is also reflected to the other side of the x-axis, and this process continues until the end point is defined. Each intersection point is defined in terms of a dot. In the example below, the intersection points would be described as a dot A equals to B, a dot B equals to C, a dot C equals to D, a dot D equals to E. The number of intersection points isn't unknown to those without a private key, thus making it is very difficult to recreate the numbers of times the equation was dotted.